Hi, folks. This is just a short note to illustrate an approach we've been working on with some colleagues from the Târgu Mureș University in Romania. This is a presentation for the SEM Working Group in Poland. There's going to be a meeting in person, but we're going to share this online version of it. It's pretty much based on a simple idea, but it goes back in time. So many decades ago, David Kenny defined a model as being an independent variable leading to a dependent variable. So that's what we're doing. We're just showing that structural or a causal thinking like this, either in this form or in a graphical form, should be the way we reason about analysis before we even talk about statistical tests like t-test and f-test. And this is pretty much inspired by an appendix from Jim Jacquard and Jacob Jacoby's book, which is this one. I just have some annotations here. So they're saying pretty much that these are causal models underlying statistical tests, which is just the idea we're presenting here. So there are some statistical tests on the left, depending on which variables you're using and what kind of variables they are. Continuous, binary, but the underlying research question or model or causal structural model is the same pretty much here. So that's what we're using as an example. We've generated some data. You can get to this blog post using the QR code or tinyurl stats causal. But to generate data, we're using a software that's pretty impressive, which is Onyx. It's a structured equation modeling software built by Brandmeier. It's free, and it's quite impressive. It opens up like this, just a blank page, but you can create a model or load data. So if you create an empty model, you can create variables and then connect them, which is what we did. We just created a model like this with 4 variables. So we have 4 continuous variables. We have some effect sizes that we specified, specific ones. And then we simulated data. You just right click and say start simulation. It's that simple. We just created binary versions of each of them in the data in Excel, so we can analyze the data in this manner. So what we're doing is pretty much using our code, our statistical software. We're running a t-test, an ANOVA or an f-test, a chi-square test, simple regression, and then we repeat the simple regression as a pad model, just for a simple setup, one variable leading to or causing the other one. Again, the R code is very easy to build. You don't need to know that part of coding. You just ask an OpenAI, which is what we did, and it gives you code for each of these analyses. And the simple point is that the analysis, the statistical tests should reach the same conclusion, whatever that is. In our case, that they are not related statistically significantly. So in other words, the predictor does not really predict or cause the outcome, regardless of the analysis you are choosing. There are other ways to estimate parameters. We're not showing that here, but you can use a tracing rule to get the regression parameter, not a p-value. But in general, that's the main finding, that you can talk about structural models or causal models in this manner before you decide what statistical test to use. And we just want to show you at the end that there are some cool modern options like this one, the model implied instrumental variable approach or DAGITY. It's again very simple code. You can just copy it from here and run it, and it's pretty self-explanatory in a way, but you can repeat this and replicate it. So drop a line if you have questions in these comments, or email, or if you find something questionable. Thank you.